Good afternoon. My name is Sharon Baxter. I work for the Virginia Department of Environmental Quality. Welcome to the Pollinator-Friendly Landscapes for Solar Facilities and Beyond webinar. This was originally planned as a panel presentation at the 2020 Environment Virginia Symposium at the Virginia Military Institute. And actually, it was supposed to be today at this very time, but unfortunately the symposium was canceled. Good news is that by moving to this online format, we've been able to reach a much broader audience, and I'm happy to report that we have more than 230 people registered. Thanks for joining us. The focus of the webinar is a project we at DEQ started a couple of years ago with colleagues from the Natural Division of our sister agency, the Virginia Department of Conservation and Recreation. We saw the huge increase in utility scale solar developments across the Commonwealth and felt that it presented an excellent opportunity to bring the research and learning that had been done in other parts of the country about marrying solar development and increasing the pollinators within to Virginia. We were fortunate to have some funding available, and we're able to hire a team of contractors to help us engage stakeholders and develop tools and resources appropriate for the Commonwealth. The names appearing on the screen are just part of the team that have been involved in this effort. I will let each of them introduce themselves as we move through the presentations. Please keep track of your questions, and we're going to use Zoom's Q&A function at the end of the presentations, and we're also recording this. With that, I will turn it over to Rob Davis of Fresh Energy, and hopefully the feedback that shows will be taken care of, and he's going to provide some context for why this initiative is so important.
Thank you so much, Sharon. It is great to be with you all today for this important conversation about how we can stack more benefits into a clean energy transition. My name is Rob Davis, and I run the Center for Pollinators in Energy, a program of nonprofit Fresh Energy. We work with partners nationwide to advance and share best practices in pollinator-friendly solar design and management. But before I speak to the big picture, I'd like to share something very specific with you all. Sun Tribe Solar, an innovative and Virginia-based company, has been recognized for having the first Pollinator-Smart and gold certified solar project in Virginia. The Pollinator-Smart program scales to fit, whether your project is 300 megawatts or 300 kilowatts. This first one is a 788 kilowatt ground mount system on 4.3 acres, a joint endeavor with Westmoreland County Public Schools. Clearly, no better place to have the first pollinator-friendly project in the state than at a school. Something that is a great example of environmental innovation and obviously sends the message that, hey, we need to be learning something here. Back to the big picture, I love talking about pollinator-friendly solar around lunchtime. The food that our livestock eat depends on pollinators, and the food we eat as well. A single fruit salad, like this one here, with these simple ingredients, requires more than 1,000 individual visits by insects to flowers. And each and every year, these beneficial insects have to make trillions and trillions of visits between flowers to help produce the food that we love. Because without those visits, these fruits don't grow, or they end up being smaller and misshapen.
The pollinators play an important role, and certainly this time of the year, we know that pollinators are visiting a lot of flowers like this dandelion. And so what we see is these beautiful yellow flowers, but what insects see is something more like this. They're really looking for the nectar and the pollen. And so the same is true for turfgrass. You know, we see these expanses of green, but pollinators see nothing. They see a desert landscape, no forage, no resources, but no carbohydrates, which are their food, and no protein. And that obviously has had a natural consequence that we're seeing huge declines in the numbers of beautiful birds and also butterflies. So the monarch has suffered significant declines over the last number of years because of these landscapes that are absolutely void of the resources that they need, the pollen and the nectar. And that then has a consequence also for all of the little birds that are busy building nests this time of the year in Virginia and around the country. And so what's exciting, I think, today is to think about the opportunities that we have now to put in this global context. There's something out that we launched into space, and we actually invented, the United States invented, and that's photovoltaic solar. We invented this technology to power satellites during the space race. So batteries were too heavy, and so we invented a new technology to power satellites for years and years and years at a time. And since the 60s and 70s, the price of solar has plummeted, absolutely plummeted. And that's just about any technology that we've seen in our own experience. Prices have absolutely plummeted. And this chart here just goes up through 2016, and the price of solar has actually fallen an additional 70 to 80% since that time. So as you can expect, again, the growth of solar has similarly mirrored the cost decline. And what's amazing is that, you know, we all online today have experienced this growth, but maybe not quite so equally. Usually you only experience solar if there's one built near you, or if you're driving by through a county that has a lot of solar, and then you start to see it. But the things that we have experienced are the growth in cell phones and the advances in the internet and growth of the internet. And so by comparison, comparing megawatts of solar installed to mobile phone subscribers and internet users, the solar industry is actually growing significantly faster. And you'll notice that so all of these charts are just from the period of 1992 to 2012. Since 2012, the solar industry has taken off significantly more. Solar was comparatively quite expensive back in 2012 compared to where we are today. But one might think that this is a perfect solution. Unfortunately, because of the birth of the solar industry in the United States has been in the Southwest, a lot of designs have heavily relied on simple designs that either use gravel or bare ground or sometimes turf grass under and around the panels. And I really chalk it up to just a simple lack of training and cross-training, because most photovoltaic or PV civil engineers think about a power plant. They think about a gas or a nuclear power plant or a coal power plant, and they're not thinking about solar as a huge, potentially fast-growing new land use. So, of course, the natural consequence when you have acres and acres of projects that look like this is that solar ends up causing a lot of conflict. And that's true whether you build a new garage or a new house, a school, a McDonald's, or a 1,000-acre solar farm. Neighbors have opinions. And so we here in Minnesota had seen this and heard from some of our allies and friends in the solar community and the agricultural community about these issues, and thought, we really, really have to figure this out. This was back in 2014. We knew we were going to have a huge explosion and bloom in the solar industry. And so we committed ourselves to a research project and found that we can import some practices and create a new way to design solar here in where I'm speaking from north central part of the country, Minnesota. And that new vision for what solar looks like, obviously in Minnesota, we thought, oh, it might look like this. And this is a typical July day in Minnesota, or like this around the typical early August day. But no, actually, we came across this photo of the West Mill Solar Park. And so our organization, Fresh Energy, we're an energy policy organization that focuses on shaping and driving a clean energy future and stacking significant and meaningful additional benefits into the clean energy transition. And so this is a landscape that farmers are familiar with. This looks like CRP. This looks like acres of flowering meadows that can support forage for sheep and other livestock. And so we imported this idea of pollinator-friendly solar to the United States, and then found this other project in Ramsey, Minnesota, at the headquarters of Conexus Energy, the largest electric cooperative in Minnesota, and then started scaling it up. The electric executive, I really give it a lot of credit to him for the nimbleness that he showed in embracing this innovation. He said that people used to just complain to him in the grocery store when their power went out, but now they come up and tell them how much they love the fact that their power company is helping to save the bees and provide meaningful benefits to wildlife. So we took this practice and have advocated and grown it statewide. This is northern Minnesota. This is in other areas. This is a NG distributed solar project, 1 year apart. And you can really see that there's a great opportunity to stack additional high performance flowering plants throughout the array area when the panels are aligned in a way. This is in Vermont. But the key is really, is this really left to the solar industry to come up with some idea of what constitutes pollinator friendly, or should we really build allies and build a coalition and use science to help guide our practices? And so we happen to have, when we started this work in 2015 in Minnesota, we happened to have MacArthur Genius Award winning honeybee scientist and one of the foremost monarch scientists in the country, Dr. Karen Oberhauser and Dr. Marla Spivak. And they were very clear and direct and told us that it is an urgent opportunity that we need more private sector investment in high quality habitat. And so we came up with this policy tool in cooperation with agricultural and conservation allies, Pollinator-Friendly or Pollinator-Smart Solar Scorecard. It is the intersection of something that is an incremental change for the industry, but a really meaningful benefit for pollinators. It's more than like planting a couple of little flowers in front of a 1,000-acre solar farm. It's making an incremental change to the seed mix throughout the project. And then have built a coalition and collaboration opportunities with the National Renewable Energy Lab. They're studying these innovative vegetation practices with an eye to lowering cost, long-term solar O&M costs, increasing generation and efficiency. And they're finding that this is incredibly cost effective. So for the companies that you know that you're working with, that you maybe work at, you just need to know, I think, that nationwide, this is one of the fastest growing trends in the country because it is incredibly cost effective compared to a large variety of alternatives like moving the project, like moratoriums, like battles over siting, like putting the panels 2 or 3 meters up in the air. Doing a pollinator-friendly landscape is incredibly cost-effective. And not only that, but in a warming world where we're seeing more and more days of hot temperatures over 77 degrees, creating that cooler microclimate under and around the panels can increase the efficiency of the panels. And there was a study just published last fall that proved this for the very first time. We're now working to replicate that on pollinator-friendly projects and not just on projects that have crops, in this case, tomatoes growing under and around the panels. So the benefits, as have been summarized by the National Renewable Energy Lab and other researchers, include additional community support, soil benefits, better chances of permit approval, reduced mower to solar contact. You just think about the number of times those mowers are clipping solar panels. Makes a very cost-effective way to reason to move the panels higher, and a number of other benefits. And then questions that obviously we need to just be clear and work through and address. But these have all been resolved over the last several years that this topic has explored at significant length. And it's not just that the communities love it and the agricultural leaders and influencers love it. It's also an opportunity for utilities to lean forward and say, well, we're going to include this in our RFP process. We want to make sure that the projects are competing on price, but also we want them to disclose whether they are practicing good stewardship practices. So Xcel Energy, one of the largest utilities in the country, is requiring a pollinator-friendly solar scorecard in their solar RFPs. Additionally, universities like Penn State, University of Dayton, Denison, and others are saying, yeah, of course, we want to compare projects that are all roughly the same price, and then we'll look at additional environmental attributes because we want these pictures in our admissions catalogs. And then brands like Cliff Bar and Organic Valley and others, they are really looking for that corporate social responsibility. They want to be able to help save the bees at scale. So, and then right in Virginia, of course, Purdue Farms. that they really want to also bring this practice to scale. So it's exciting what is happening nationwide, and it's particularly invigorating to work with folks in the Commonwealth of Virginia, which I believe has one of the best programs set for the most success. And so with that, I'll turn it over to Renee.
Thanks, Rob. So this is Renee Hypes with the Department of Conservation and Recreation, Division of Natural Heritage. And as Rob has pointed out, there are many benefits to planting native plant vegetation on these sites, including environmental benefits and agricultural benefits, sustainable locally adaptive plants, to reduction in the use of pesticides, to increasing pollinator service for agricultural lands. As many of you know, there's been a reduction in the pollinators over the last several years, with some areas seeing a reduction as great as 40%. One of the major causes in the reduction of pollinators is the loss of pollinator habitat. Monarch butterflies are charismatic pollinator indicator species, and their return in numbers may help guide how we are doing on our recovery of our pollinator species in general. Some science behind the agricultural benefits of the planting of native pollinator habitat. In 2013, TNC and NRCS study calculated the cost of the installation of 1 acre of pollinator habitat for 24 acres of crop production. The analysis was the percent yields per crop directly related to wild pollination and determining the production boost in dollars after implementation of the habitat. Though this may be a little bit difficult to see in the right-hand corner of the slide, if you look closely, you can see that squash had an 81% yield from wild pollinators, with a production boost of over $1 million. Other fruits and vegetables, including blueberries, watermelons, bell peppers, were at a 10% yield from wild pollinators, with thousands of dollars in production boost. Another study in 2018, which was really a GIS analysis, looked at all of the proposed and existing solar facilities in the US and the agricultural lands within 1.5 kilometers, which is the pollinator foraging distance. If you take a look, you'll see that approximately 3,500 square kilometers of land, which is close to the size of Rhode Island, was identified assuming that pollinator habitat was established on these sites, meaning that these agricultural lands in close proximity to these particular solar facilities would be a huge opportunity for increasing pollinator habitat. So continuing to look at environmental benefits from planting of native pollinator species, if you take a look at these two photographs, it basically looks like that if you were to take a guess, which one would be more sustainable in terms of reducing soil erosion over time. My suggestion would be the right photograph. Certainly with the density of pollinator species that are there, you would make the assumption that there would be less runoff and less soil erosion compared to the left photograph where you're seeing dirt roads and minimal vegetated areas. One of the reasons that you would assume that there would be less runoff are the deep roots that we're seeing from the native grasses and forbs shown in this diagram. Some of these roots actually go to the depth of 8 feet. In addition, these long roots will help the soil fertility by creating tunnels for waters and nutrients, as well as sequester more carbon than the compared turf grass with a maximum root depth of 3 to 6 inches. So beyond benefits for the environment and for agriculture, there's also benefits for the solar industry. Anything from long-term maintenance costs being reduced over the life of the project to aesthetic appeal of a solar site. Taking a look at this graph, comparing mowed lawn to restored native plant habitat, A study was conducted in the Midwest part of the United States, looking at a cost-benefit analysis of the cost of maintenance of the two different facilities, one having a mowed lawn and one having a restored native plant species habitat. As you can see, the maintenance cost of the mowed lawn is high throughout the 20-year period, and the maintenance cost of the native planting is much lower, only requiring mowing for some of these native plant habitats once or twice a year out of the growing season. The break-even cost for the installation compared to the turf grass maintenance, depending on the cost for the native seed mix, could be anywhere from 3 to 7 years. We currently do not have any similar studies in Virginia yet, as we are just starting to develop solar in the Commonwealth. But the plan is to conduct those studies in the coming years and show the same reduction in long-term maintenance cost. Due to the decrease in mowing requirements, you would also expect for solar facilities to have less damage to panels and infrastructure from maintenance operations. Also, as Rob has pointed out, the regulation of temperature by native vegetation on these sites could allow for maximum efficiency in terms of energy production by the solar arrays. Another benefit from planting pollinator species within these solar facilities is curb appeal. Looking at this photo, a field of wildflowers blooming throughout their growing season can be more aesthetically pleasing to the surrounding community and a huge selling point to the local government.
Okay, hi, this is Sharon Baxter again. I'm going to do this part for my colleague Beth Major, who's not able to be here today. We thought it was important for you all to get a sense of where we are in solar. Renee just referenced it's a relatively new thing in terms of large utility scale development, but it's happening at a very rapid pace. Next slide. About 8 years ago, DEQ developed what's called the Small Renewable Energy Projects Solar Permit by Rule regulation, with the idea being to facilitate a faster process for permitting. We've been operating under that since 2012. Since 2015, we've issued 45 permits, and these are for projects that range from 5 megawatts to 150 megawatts. And that has totaled 25,000 acres. Beyond that, there are currently an additional 62 new projects in the pipeline that have been proposed, total an additional more than 36,000 acres. The regulation, and many of you who are listening might have been part of the process, has been going through a regulatory review or revision over the last few months. And it is currently in what we call executive review with the governor's office. At this point, I'm not able to predict when it will be released, given everything else that's going on, but that is in the works. We expect the demand for solar to continue to increase for all the reasons that Rob mentioned, but just for also some priorities that have been set here. Last September, our Governor Northam signed Executive Order 43 that has a number of clean energy goals, including that 30% of our electric system will be powered by renewable sources by 2030. And also that 100% of electricity when we reach 2050 will be carbon free. There are also some goals related to increased purchases by state facilities and so forth. So we expect that it will continue to drive the demand. And then finally, I just wanted to point out that these projects are all over. For some reason in the Eastern Shore, oh no, there it is, yeah. Eastern Shore, you can see on the left there. They're, from all areas of the state. And the check marks are ones in place, green are proposed, and stars are operational. But we expect to see more and more. And with that, I will turn it to Doug, I believe.
This is Doug DeBerry from William & Mary and VHB. The state, in response to Governor Northam's executive order, which I guess is not the most interesting executive order on everybody's mind at this point in time, but still an important one and certainly one that's preeminent in our minds for this particular talk. The state issued an RFP to put together a team and to think about ways that the state could build a program. And so what I'm going to just talk to you about is how VHB assembled the team under the auspices of DEQ and DCR's request for really a program development contract. So what we were looking to do was really find a contingent of teammates that would represent every aspect of this RFP that DEQ and DCR put together. That was issued in, I think, the middle of 2018, and we got under contract in the fourth quarter of 2018. And one of the things that, I'm not sure what happened to the video there. So okay, back online there, good. So obviously DEQ and DCR are the most important aspects of that team because they represent the state and the program they were trying to develop. And really our team from counterclockwise from the left there, Rob with Fresh Energy, Pollinator Partnership, Prairie Restorations, Ernst Conservation Seeds, Granby Environmental Consulting, and then Ernst Pollinator Services, which is a division of Meadville Land Service. This is a group that we felt provided not only the management and science, but also really the administrative element of things and how we would dovetail with the public. Well, priority one for us under this contract really was to look at the existing programs that were out there. And as Rob mentioned, following the lead of the state of Minnesota, there were several states that had presented their own scorecards for this sort of initiative, figuring out how to take this kind of solar concept of native plantings and pollinator support and develop it into an index that could be used to, as Rob said, really a different model for approaching these sites and their management. And of course, that's built on really some very important thinkers and not only academia, but also the industry. Another part of this for us, really the first half of the contract term, which was a year, was to look at also the scientific literature and figure out how what we were finding from that literature could support what the state's initiatives were under this program. And anyone who is interested in that particular lit review is welcome to download the comprehensive manual, which I'll talk about in a minute. But there's a detailed, obviously, list of references there. So that's available to you. From a plant biology standpoint, of interest to me is not just the ecological support services for pollinators, but also the plants themselves, the composition of the species. And so we put a lot of time and energy into reviewing not only the sort of watershed moment that occurred when the Flora of Virginia was first published in 2012, but also all the incredible hard work that Natural Heritage under DCR had been doing to develop databases for the public to access information that was housed there. And I really have to take a minute and compliment DCR and DEQ for including stakeholder engagement as a component of the RFP for this project. That was incredible insight. And I will say that it was probably one of the most important aspects of this program development over the year. That's an aggressive schedule to put this much energy and information together under one package state. And so our team put together 3 stakeholder meetings. They were June, July, and August of 2019. And you can see from the list of attendees, we had really a very diverse group of attendees and stakeholders from the entire, really the entire spectrum of stakeholders, and also from the public and private sector. And this was incredibly important. I mean, you know, just from a personal standpoint, as somebody who poured over hundreds and hundreds of references, you know, you can walk into a meeting like this thinking you know what there is to know about a topic, and then leave a meeting like this with 12, 15, sometimes 20 new ideas to incorporate into the program. And that's what happened. So our teammate, Granby Consulting, helped to facilitate those meetings, and they took assiduous notes. We had flip charts, we had all kinds of diagrams, and everyone was given a voice. And it it moved the program forward in a very positive way. Folks can go onto the DCR website where the project documents are posted. I don't have the URL up here, but if you just Google Virginia Pollinator-Smart Program, it'll come right up. And we have 3 main project documents that were produced by this RFP. The first one is up in front of you. That's the comprehensive manual. And the intent of this is was to provide everyone with basically a full compendium of program participation. So all of the science that went into the ideas, the background understanding of the program itself and the foundation for it, and the goals and objectives. Also included in the comprehensive manual is the scorecard, which is the Virginia version of that scorecard, as I mentioned, that Rob mentioned, started in the state of Minnesota. Those are embedded in that program, and we also have sort of a user's guide for how to get through from beginning to end through the program. The 2 other documents available on the website are a Pollinator-Smart monitoring plan. This was, the idea behind this was really to figure out a way to sort of formalize a monitoring program for solar sites, which are fairly unique. They're not your typical ecological study site, but also to maintain ecological sampling criteria. So the idea was to make sure that we are figuring out a rapid assessment of technique. It would also get the information that was needed to assess whether these sites were performing as designed. And then that last document down there is a business plan, and the business plan will be addressed a little bit later. I do want to mention there's a 4th sort of product that's not listed here. It was a tacit product. The team was actually asked to weigh in on the Virginia Solar Site Native Plant Finder. And so we were providing input on that particular tool. It's a web available database review tool, and that'll be also discussed a little bit. So I just wanted to walk you through a really brief expose of how a site might run through participation in this program. And go ahead and go to the next slide. If anyone is interested, feel free to download the comprehensive manual. And if you do, at the very beginning of that manual, you'll find an executive summary that we refer to as the Pollinator-Smart Program at a glance. You'll see this particular flow chart. And if you can get kind of the sense of the timing for this flow chart, you would pretty much have participation in the program outlined very well. So the idea is that if you have a new site or you have an existing site that you'd like to retrofit with a Pollinator-Smart management regime, then we are strongly recommending in the program you start with site suitability analysis. It looks at all aspects of the site that might relate to how to encourage and incorporate native species into your planting plan. Site suitability analysis, if you're interested, is covered under Chapter 2 in the comprehensive manual. The next step would be to develop a vegetation management plan. And I hasten to point out that although the vegetation management plan is optional in the program, in other words, you're not required to have a veg management plan to participate in the program, it is strongly encouraged, because if you follow the steps in the outline to develop a vegetation management plan that are in the comprehensive manual, which is under Chapter 3, then most of the documentation that would be required to submit would be available to you. Could you back up a slide, Rob? Sorry. I just want to mention that there are 2 scorecard versions in the state of Virginia, and I didn't point that out earlier. There's a version A and a version B. If you have a new site or a retrofit site, you're using version A. And if you have an existing site and you're just assessing whether it still meets Pollinator-Smart criteria, use version B, which is the next slide. There is a 21-day review period once a scorecard is complete, and the review board looks at that. The review board right now is composed of state natural resource agencies and members from academia. If it turns out that the submission is approved, then you are certified. So once the site has gone through the installation process, we recommend an annual site inspection. But in the certification process, you would submit a scorecard every 2 years. So at the outset, and then in years 2, 4, 6, 8, and then finally in year 10. And in each instance where you are reviewing an existing installation, you're using the version B of the scorecard. Okay. And then embedded in this process, of course, is that if the site is not meeting standards or criteria, there are remediation tactics that are implemented that can be incorporated into the scorecard. And then finally, after 10 years of showing that a site is meeting the criteria, it is again subjected to a review process. And if it passes, then it is considered a lifetime Pollinator-Smart certification. And I hasten to point out also that this is contingent on the fact that a long-term management plan is also submitted. So that's kind of the process in a nutshell. I'm going to go ahead and turn the podium back over to Rob, but I want to thank everyone again for participating and taking time out to tune in.
That was great. Thanks so much, Doug.
Yeah, Renee, so this is Renee Hypes again. So Doug mentioned about another resource that was actually enhanced during the development of various resource products. And that was the Virginia Solar Site Native Plant Finder. The Plant Finder existed before, however, it's been enhanced with various attributes in terms of characteristics that can be looked at for searching as well as reporting. So that was a huge increase in the available information on the application. So the Solar Plant Finder application has over 1,600 species, native species within the actual database. Currently, we have 278 native species that are commercially available. With the application, you can conduct queries by locality. If the solar facility is located in Botetourt County or located in Accomack County, that can be selected. Also understanding what requirements you're looking for in terms of light requirements, full sun, shade, water requirements. Are you looking for a particular timing in terms of flowering? And also, what is the expected maximum requirement that may be for that particular species? And then once you put in those particular characteristics, you then can get results back in a tabular form, which gives you details about the species, including its habitat, where it's found in the state. There are also links to the digital atlas as well as to commercial vendors. This is just a screen capture of the interface of the Solar Native Plant Finder. And again, as I mentioned, you can query by a variety of attributes. You certainly also can just search by common name or scientific name for a particular species. And then, as I mentioned before, depending on what your requirements of your site are, you can actually toggle or determine by characteristics what your search needs to be. Certainly we've mentioned most of these. Another thing is to think about plant type. It could be for an herb, it could be for a tree species, it could be for a grass, it could be for a sedge species, just again, depending on your site conditions. And certainly for the tree species, considering maybe some of the screening areas on the facility, using native plant species. It automatically defaults to commercially available. You can change that if you're looking for all native plants that may be found in that area, but it just is set to default to what we have available as known by what vendors have provided to us. Next, please. So if you take a look at the report information, as we mentioned, the various attributes, scientific name, common name, light and moisture requirements, the plant type, how tall is expected to be, is it a pollinator species? And the database is made up of native species and some are pollinator species. and then the flowering season. And then, as I mentioned, if you click on more detail underneath each of the records within the report, you can then see the link to the digital atlas of the Virginia flora. It gives you also photos of the particular species that you're looking at. And then there's the commercial availability that I mentioned that actually has hyperlinks to each of these vendors, and then gives you habitat as well as synonyms for the scientific names when searching for a particular species. Next, please. So a characteristic or an attribute that's not currently in the plant finder at this point is Virginia ecotype. And when I speak of Virginia ecotype, I mean the genetic makeup of a unique species occurring here in the state. For example, species not occurring in the state, but occurring in other states, partridge pea that available native seed is available for is available with a unique Florida ecotype and a Pennsylvania ecotype. So this is an important long-term goal for the Pollinator-Smart Program as we start up a native seed here in Virginia. We understand that these local native ecotypes have a lot of good qualities that we would like to pursue in our native seed program, including that they're genetically adapted to local conditions, that they are actually, they have evolved with local pollinators, insects, and birds, and provide food and shelter and habitat for those animals and resources, and also to preserve the genetic diversity and integrity of native plants here in the Commonwealth. So just a quick walkthrough of the business plan that Doug mentioned earlier. This was developed again with the mindset that as we move forward in encouraging planting and establishment of pollinator habitat, that we would also look to establish a Virginia native seed industry, and that the overall business model for Virginia would be to build out minimal infrastructure to deliver a rough condition product to a facility capable of conditioning the seed to go to market. And that is laid out in the business plan, that there would be a Virginia Native Seeds Grower Business Advisory Committee that would provide support to the local Virginia growers through marketing, mentorship, and financial support. And the committee would also help identify growers for the program and provide the seed. And then using shared infrastructure, including seeding and harvesting equipment that would be available to the farmers in the program, they would then help in oversight of the planting and the harvesting of the native seeds. Once those seeds are harvested, they would then be sent to a commercial facility for processing and distribution. As a part of the Virginia Native Seeds Grower Business Advisory Committee, there would also be a Virginia Ecotype seed group. And that seed group would be responsible for the collection, the grow out, the certification, and the increase in that seed availability to those farmers to grow. So there are seed programs that have already been successfully established in other states. One of those is the Arkansas Native Seed Program. That was established by the Arkansas Native Heritage Commission in partnership with a dozen other agencies and nonprofit, including Audubon, Arkansas, to seek out and work with farmers willing to grow wildflowers and grasses to produce large quantities of locally sourced native seed for use in wildlife restoration projects. Next slide, please. The concept is similar to what we're talking about in Virginia, that the farmers would be provided with 2 or 3 species of native seed, and then those farmers would grow them out on approximately 10 acres of land. That material would be harvested and then shipped, and is currently being shipped to Roundstone, a native seed facility in Kentucky, for processing and distribution. So this is the same idea as what we're thinking of for Virginia. Another successful program is the Iowa Ecotype Project, where it was mandated to develop seed of the highest potential quality for the greatest genetic diversity, with the intention of restoring prairie land in Iowa. The program started in 1990 and as of 2011 has over 800 acres in production. Over its history, it has increased seeds of 50 different species from 3,000 populations in Iowa, including 81 ecotypes of 33 species released for commercial production. And they're producing around 60,000 seeds annually. Now I'll turn this back over to Rob. Thank you.
Thank you all so much for participating. For next steps, Katie.
Hi, this is Katie Cyrus. I'm an environmental scientist with VHB, and I've been helping develop the Virginia Pollinator-Smart Program with the rest of the team for the last year and a half. We officially launched our program earlier this year. The materials were uploaded in December, and the program was officially rolled out in March. Since this is a newly launched program, we want to hear your opinions about it, about the materials, about what we can do moving forward. Part of this will happen in today's Q&A, but additionally, if you have any questions or comments, please email us at pollinator.smart@dcr.virginia.gov. Last year, we held 3 stakeholder meetings consisting of a diverse audience that included solar developers, state and local government, nonprofit organizations, and more. We'll continue holding stakeholder meetings this year, but we will aim to target specific audiences in order to get a better understanding of each group's input. Given the recent pandemic, we have yet to announce our first stakeholder meeting, but it will most likely be held virtually. Again, if you're interested in participating in these, please don't hesitate to reach out to us at pollinators.smart@dcr.virginia.gov, and we'll include you on the mailing list. We hope to try to create a silver lining out of our new normal. So towards this end, we'll be organizing a workshop series for interested participants that will take a more interactive format, but will also be held virtually on a platform like this one. Preliminary ideas for workshops include how to create a vegetation management plan, how to design a monitoring plan, and how to complete the scorecard. So as you can see from these topics, these will be down in the weeds. So it's intended for people who already have a location for Pollinator-Smart planning in mind, or will be likely to implement the Pollinator-Smart program on their sites in the future. We'll also be continuing to develop the portal, which is www.pollinatorsmartva.org. I already sent the link in the chat, and it will also be, this link and the email will also be provided on the final slide if you miss it right now. We'll be providing a recording of this webinar on the site in the next few days, as well as PDFs of the presentation. This website is where we host the entire program and all of the relevant materials required to participate. So if you want to access the latest versions of the scorecards, the comprehensive manual, the business plan, or the monitoring plan, then please visit the portal. Additionally, we are planning to launch the Virginia native seed industry using the business plan this year. We'll first get in contact with the Arkansas Native Seed Program and the Iowa Ecotype Project to learn more from them. And then after that, we'll form the Virginia Native Seed Growers Business Advisory Committee, containing smaller subcommittees of the items listed below, which are Market Development Group, Ecotype Development Group, the Grower Development / Consulting Group, and the Grants and Financial Group. Concurrently, we'll be working to locate available growers within the region. If you're interested in getting involved or have suggestions for us in these early planning stages, please contact us at the email, which again is pollinator.smart@dcr.virginia.gov. If you missed the web address or the email, then again, they'll be provided on the final slide of the presentation. Next slide, please. All right, I turn it back over to Renee.
Thank you, Katie. So now to talk about and beyond. Next slide, please. So this idea of planting native plant species, including pollinator species, can be applied far beyond solar facilities. Here you see on the slide a list of the different opportunities that can utilize pollinator species. For instance, brownfields, including reclaimed mine sites and Superfund sites, could be great candidates for revegetating the sites with native pollinator species. The Atlantic Coast Pipeline and Mountain Valley Pipeline, working in consultation with DCR and others, have developed seed mixes to include native plant species in their maintained right-of-ways. In addition, transmission line projects, due to their open canopy and maintained right-of-ways, provide suitable habitat for the planting of native pollinator species. The Virginia Department of Transportation and the Blue Ridge Prism Group have worked along with DCR to consider the planting of native species within their right-of-ways. Also, the removal of invasive species as part of their seed mixes, and potential funding of research to determine which native species are the most suitable for Virginia's roadside right-of-ways. VDOT has also established native pollinator areas at some of their rest stops. The Interagency Wetland Mitigation Banking Team has discussed the potential use of native pollinator species on many of their proposed banks. Native pollinator species could also be the future crop for some farmers. Parks and schools and landowners have opportunities to consider the planting of native plant pollinators as part of their landscaping plan. Research has shown as little as a half-acre of pollinator habitat can benefit pollinators. As a matter of fact, Virginia's first Pollinator-Smart Gold certified solar site is the Copel Elementary School in Westmoreland County. And with that, I'll turn it back to Rob.
Great, thank you all. We still have nearly 200 people on the line. We're really looking forward to getting to your questions. I think one of the first and most exciting questions that we have right off the cuff is just how real is this? I think this is really a question for Robin Ernst. And Robin, I'm going to some slides showing some pictures from Copel Elementary School. Could you introduce yourself and talk about this project a little bit?
Sure can, and thank you very much for having me. This is listening to everybody and their excitement of what's going on with this industry is great, and I feel like this is where we really meet the road here, is being able to install these natives in this particular site at Copel Elementary. You can see we were utilizing a native seed drill. We like to make sure we have a good seed soil contact when installing the seeds, and then also scarifying the soil to make sure we have a good seed soil contact. This was a small site, about 5 acres, and it was a retrofit. It was a site that was originally just grasses on it, did not provide much benefit. What was important was when eradicating the invasive species such as the fescues, we wanted to make sure we had a good ENS in place, and so we put a cover crop in with this native seed mix, and then we were able to help stabilize the site first and foremost, and then wait for our natives to come along. Are important when you're establishing your site, and they can be utilized in 3 different seasons. After that, then we're looking at a 2 to 3 year period of establishing the native grasses and wildflowers. The native grasses and wildflowers can be maintained during that time in a small amount with some and spot sprayings that can help to eradicate invasive species and allow for the native species to flourish. As you can see now with the screenshot that is up, there is a drag going underneath the panels to scarify the soil. So we again try to get a good seed to soil contact. And as you can see on the right-hand side of the photo showing, that is a native seed drill. And I say native seed drill because it is important that these native seed drills are utilized, not just a regular grain drill, because they have systems to feed through the warm season grasses and the forbs. Next. I guess this goes back to you, Rob.
Great. Thank you so much for hopping in there, Robin. It's great to know that it's not just a beautiful 5-acre project, but it's the first one to be gold certified in the state of Virginia. And now we'll, I think, start getting through some of these questions. We've had questions come in over the last 75 minutes or so, both through the chat screen as well as through the Q&A. If you have a question, if you have an additional question, look below in your screen, hit the Q&A button, and type your question right into that, and we will get to that. For the ones that we don't get to, we will follow up with folks via email directly. And so maybe, Robin, could you there's a question that came in through the chat, specifically regarding sheep and bees. Are these two things competitive or complementary? I understand that you guys might have some experience with that in other states as well.
We do. We actually have worked with the American Sheep Grazing Association, along with Cornell University and Ernst Seed and Ernst Pollinator Service. And we have developed what they call the fuzz and buzz mix. And that mixture is used specifically to benefit pollinators, but also benefiting, which can be done effectively on solar sites. So yes, this is a great combination that can be done if the sheep grazing is done in a managed degree.
That's right. The key is the American Solar Grazing Association recommends rotational grazing, never do continuous grazing. The two practices are very different. So you want to make sure that if you do grazing on your solar project, you do rotational, not continuous. Renee, a question for you that came in via the chat, and then we'll get to the Q&A. The best contact, who is the best contact regarding seeding specifications and management techniques? Is that really up to private industry and vendors, or is there going to be a clearinghouse or some other solution should folks be coming to you guys?
So I would say initially it would be up to developers and vendors to identify what's being proposed for that particular site, as of course it would be on a site-by-site basis. And then as part of the review committee of the scorecard that's submitted for certification, we would have a conversation and discussion with the developer to determine if that's the best approach, or if we have recommendations, we would provide that information at the point that we talk to them if they've submitted their scorecard. They certainly can always call us and contact us beforehand, but it feels like just from the one that we've done so far, it's easier once we have the information in front of us.
Great. And then one more question, Renee. Will DEQ have design guidance available for VSMP authorities to use when reviewing the development plans?
So being a part of DCR, I would put that over to Sharon if she could maybe respond to that for DEQ.
Sure. Our stormwater folks have been part of the our initial stakeholder engagement during the phase 1 developing all these products. And as Katie mentioned, the next stage of this project is to do some more targeted stakeholder outreach, particularly with local governments. It's one of the most important audiences. So we don't have that right now, but that's certainly something we're very mindful of needing to connect those dots.
And then a question that it comes up in a couple of different, has been framed in a couple of different ways, is around incentives and having a national perspective on the movement to embrace pollinator-friendly solar landscapes. My answer to that, just default answer to that, that's not Virginia specific, but it's really looking nationally, is to pose the question back to the group and ask whether or not Blockbuster had any incentive to start renting videos online. So the reality of what's driving the market is that you, a solar developer, you are looking for an edge that's not just a price. And your customers are increasingly aware of pollinator-friendly solar designs, and so they're going to be asking for it. And if they're not asking, you should be offering it because you want to beat out your competition. And increasingly, it won't be just on price. It'll be on additional environmental or agricultural compatibility and other features. So you want to make sure that your project gets onto the short list, and then when it's among the shortlisted projects, that it wins well on price, but also has some distinguishing characteristics that make the CEO and the executive team or the mayor and the city council look like absolute heroes. So let competition drive you, and know that that this is a tactic you can use to beat out a regular old school solar that might be turf grass or gravel. The photos are really something that you can use to accelerate your permitting process and get more projects done in a year compared to the delays and litigation that other projects often draw. Other questions, Robin, back to mowing and seed mix design. Is there a specific mowing regimen? Is there a calendar, a time to mow and not mow? And maybe Katie or Doug, you guys could chime in on this as well. Mowing and seed mixes.
Okay, as far as the seed mixes, we do want to approach every site as being different. Every site should be evaluated based on soil conditions and what the end intention is to be from the developer. You know, what is your goals and what you are looking for. So the seed mix can be developed per each site. The other thing is that when you're mowing, what's important is in the early spring, when you seed out these mixes, if you seed them in early spring or seed them in late fall for a dormant seeding, that the early spring weeds tend to get a little bit of ahead of the native vegetation. So what we want to do is we want to do a mowing no lower than 8 to 10 inches so that we can take out that shading factor of the invasives and allow the sun to penetrate down into the native warm seasons and the native forbs and let them have the chance to get going. So a mowing in the early spring, or not early spring, I should say, summer around mid-June is to take place, but no lower than 8 to 10 inches. And then based on how the mix or how the species proceed, we would want to do another mowing in about September. Doug?
Yeah, so thanks, Robin. That's great. And one of the things that you said before reminded me, so VHB wrote the vegetation management plan for the Copel Elementary site, the first certified site in Virginia. And it's very, very important to say that while we were preparing that, we worked directly with Robin and her team to make sure we were bouncing ideas back and forth. So folks who are contemplating this, very important early on that you compose your team of teammates that are willing to work together, both from the contracting side or implementation side, and also from the design side. That's very important. The other thing I'll mention is that when folks start to download the materials that Katie gave you the link to on the Pollinator-Smart website, if you look at the techniques, site suitability analysis, and then the programmatic requirements for Pollinator-Smart, you'll see that there are specific definitions for seed mixes and how they qualify for the program. For example, to be what we call a Pollinator-Smart seed mix, there are certain criteria. You need at least 3 native grasses, and that idea is to create structure within the meadow type community that's there, and then also a minimum of 20 species. And so I'm going to try to cover a couple of these questions that I saw. One of the questions was the concern about the shade from the panels. Really, the panels, the biggest concern that we had from implementation was how Robin was and other folks who are implementing these techniques is going to get their gear in between the panels. And so, someone like Robin has figured out a way to do the drag and so forth, verify the soil, and get our equipment up and down there. So that problem is getting solved. On the shade side, because these facilities are built with panels that tilt over the course of the day, the shade is not consistent. You're not, there's very little place underneath the panels that's going to be in the shade 100% of the time. And so the idea behind the diversity of the seed mix is that you're going to incorporate species that can handle a diversity of conditions that are out there. So in terms of composition of species and everything, right now we're using the Solar Site Native Plant Finder as the sort of the arbiter of which species are appropriate for the seed mix. And there's going to be some back and forth, as there was, Robin will remember, with Copal, to make sure that we could get a seed mix that would work with the goals and objectives of the state program. And we did.
That's fantastic. Thank you, Doug. A couple questions came in with regards to height of the panels, and that definitely affects shading. Just so that folks know, a baseline rough estimate back of the napkin math number is that an additional 12 inches of height results in more steel that you have to put into the project. And the cost of that additional steel is roughly $2,500 to $3,500 per megawatt. So $2,500 to $3,500 per megawatt gives you an additional 12 inches of height. That very quickly pays for itself in reduced mower to solar contact. And you also have better establishment of the vegetation under the panels because there's more indirect light that's reaching underneath. So adding height to panels, particularly as long as the construction company and the builders can stand with their 2 feet on the ground, pick up a solar panel from a pallet and screw it into the project, that's the key. The minute they have to get additional equipment to go up higher, say their shoulders or higher, then the costs go up because the labor costs go up. And then also, with regards to flowering habitat, yeah, you think, oh, well, this is going to be fantastic, but won't the pollen from the flowers have a negative influence on the generation? So the short answer is absolutely not. And the detailed answer is the reason you have pollinators is because all of these flowers are holding on tight to their pollen. That's why you need a butterfly or a bee or a moth or another insect to go and get in there and grab the pollen and then take it off and bring it to another flower. Other plant types like corn or trees are wind pollinated. So those plants are dumping copious amounts of pollen into the air. And so if you ever see pollen on your solar panels, it's probably corn pollen or tree pollen. And I'm sure that we're going to continue to build lots and lots of solar projects near corn and near trees and other things that are wind pollinated. So the Pollinator-Smart program does not increase the abundance of pollen on panels. If anything, it creates a cooler microclimate that helps the panels become more efficient. There's very good data with regards to how these systems work. And not just on the small ones, but on very large ones as well. Other questions? I think we just have time for 1 or 2 more. I will encourage you to look at the URL as well as at the email address. If you had questions for individual panelists as well, you can find me through the website beeslovesolar.org, and then VHB is just, I think, vhb.com, and other panelists. I guess Renee and or Sharon, would you like to just have some closing remarks about how the program has developed and what your hopes are for the growth of the program over the next year and 2 years?
Okay, I'll start. This is Sharon. As I said, this was a rare opportunity where we actually had funding and had a need and had some very enthusiastic partners and great resources to work with. And so we are super excited with where we are, but I just want to remind people this is just kind of phase one. It was a lot, I saw some of the comments about how impressed people were with the products. As Katie said, we've just really officially rolled these out a couple months ago. We are trying to not only do those additional stakeholder meetings, but looking at getting additional funding to perhaps do a pilot project. There were some questions about, maybe offsetting costs for people to gather seeds. There's so many ways that this could go. Unfortunately, we don't have a lot of funding at this point. So we're going to try to be creative, but we want to see more projects like the one in Westmoreland County and hopefully be able to track them and track their success in Virginia. That's what I think will be key.
And this is Renee, and I'll just add to that, totally agreeing with Sharon on the excitement around this program. We certified our first Pollinator-Smart site in January of this year, and just looking forward to the future and what that's going to bring in terms of ideas and creativity and opportunities. That's just glaring for me at this point to see that this is just a huge opportunity for us to increase pollinator habitat, and just hopeful that others see the same, and that certainly if you have any questions, as it's already been expressed, please feel free to send an email to pollinator-smart@dcr.virginia.gov or any of the panelists. And we absolutely appreciate the time you've spent with us today, and hopeful that you will have questions in the future and that you will reach out to us. Thank you very much.